Hello! This video tutorial will walk you through setting up a model for a ClimateStudio daylight simulation. Let's open Rhino 8. If you've never had ClimateStudio installed before or haven't entered a license, you'll be prompted to enter one. Trials can be requested from the Solema website. To begin, run the command ClimateStudio. This will bring up the main ClimateStudio user interface. The first dropdown will cycle you through all of the available workflows. With the daylight availability workflows selected, let's review the second dropdown, which lists all of the available sub-workflows. This includes daylight standards and rating systems such as LEED, BREEAM, EN17037, and daylight factor. The custom daylight availability workflow is where you can set your own custom illuminance targets and occupancy schedules. For this tutorial, I'll select LEED version 4.1 option 1, one of the most common workflows used to calculate LEED daylight credits. Before we go any further, I need a model to work with. The command CS example files brings up a collection of Solema created models for daylight and energy testing. I'll select the classic office floor model. I can see two design options for this office in the Rhino Layers panel, base case and option 1. By turning one or the other off, I can compare the differences in the facade and glazing design. For now, I'll choose the base case design. Additionally, I'll quickly turn off the furniture layers. This is because LEED allows that furniture and partitions under 36 inches from the finished floor to be excluded from the simulation. In this case, the furniture in my model is around 30 inches high. Many subpanels, such as location, are the same across most workflows. By clicking on the location input, you can review crucial climate statistics such as the climate zone, average temperature, solar radiation, and wind speed, as well as heating and cooling design conditions. To change the location, click on the folder in the top left corner. Users can upload their own EPW climate file from their hard drive or browse through the available climate files to download. Below the location subpanel, we have the materials, areas, and scene assets inputs. A Revit file can also be imported here using ClimateStudio's daylight export function inside Revit. Now, let's finish filling out our inputs. One of the most important tasks when setting up a model for a ClimateStudio simulation is adding your occupied floor areas or simulation grids. In the Areas input, click on the top left Add Occupied Areas button. Up in the Rhino command line, it'll ask you to select surfaces or meshes representing regularly occupied floor areas. I'll open the Layers panel and right-click the Grids layer, selecting all objects and pressing Enter. Here, I can adjust things like my sensor spacing and inset. My occupied areas are also now listed in the ClimateStudio Workflows panel, and I can use the Edit button to change the specific details of each room. Let's look at the Materials panel. Each object in a Rhino model is located on a layer. ClimateStudio uses these layers to assign material properties to scene objects. When setting up a model, objects with different material properties should be placed on different layers, each assigned an appropriate material. Objects on layers without an assigned material are ignored by all lighting simulations. Since we are running a LEED daylight simulation, let's make sure that a dynamic shading system is set to our exterior glass, which is required to receive LEED daylight credits. I'll click on the material for the base case's glazing and make sure that the material library is set to exterior glass with dynamic shade. Here, I can change the glass material, and shade controls. I'll go into the Shade Material panel and review the information on the selected fabric shade. Let's select another layer and peruse the material library a bit more. I'll click on the floor layer, which has been pre-populated with LM83's standard matte material. Choosing LM83 default materials is ideal when you don't know or don't have the scope of what realistic materials you'd like to assign to your model geometry. If you do know the realistic materials you'd like to use, the material library can be sorted by type, surface, roughness, or visible light reflection and transmission variables. Other material libraries include interior glass, scheduled and custom materials, and dynamic snow and tree leaves. Don't forget you can also search for materials. Next up, let's click on the Scene Assets subpanel. The new ClimateStudio 2.0 update now facilitates the modeling of trees. I'll select a short and sparse tree, adding one of these blocks into my model. Looking at the materials input, I can see that this new tree is now on a separate layer that includes twig, trunk, and leaves. If I click on the leaves layer, the material selection for dynamic leaves pops up, and I can alter the leaf type. By default, the trees created by ClimateStudio are deciduous, and the leaf schedule is temperature-based. Foliage disappears and changes color depending on the latitude and the time of year. To make the tree behave as an evergreen species, you can edit its materials after placing the block. I've now filled out all of my inputs as needed. Before I press run, I'll click on the settings button on the right to review my daylight simulation settings. This is where I can adjust my GPU or CPU allocation and set the number of ambient bounces or samples. Everything looks good, so I'll press run. We will review the results panel in the next video tutorial. Thank you for watching and happy simulations!